Thanks to Reddit here, I'm just diving into some subjects here. A user says that polycarbonate glass, just about any standard material that we use as clear material, does a pretty solid job of blocking UV light. But I don't want to block UV light. I want to pass through all the UV light that's coming from my diodes. So I ask the all-knowing chat here, and it tells me, hey, try quartz or fused silica. So I found one here that I'm going to get ordered. It's relatively inexpensive, 13 bucks. That just saved me a ton of even frustration. Obviously, this wasn't going to work. If UV light energy can't be passed through the glass, then that's killing most of the energy going through that glass. We have to transfer it all. So we're going to use these, and maybe that's a setback that some of these people are using with these types of gas chambers if they're trying to make a resonant chamber and photon injection. If they're using acrylic or polycarbonate or any type of PVC or plastic, it's blocking the useful frequencies that you want to pass through. So we're going to order this and do it from that. Okay, I found it. I was searching and searching and searching for this in my quest for photon injection here. First, water molecules are split into component atomic elements, hydrogen and oxygen, by a voltage stimulation process, which we're doing, which also releases dissolved gases entrapped in the water. In the injector assembly, a laser-produced light wave or other form of coherent electromagnetic wave energy capable of stimulating a resonance within the atomic components is absorbed by the mixture of gases, hydrogen, oxygen, ambient air gases, released by the polarization process. So, I'm looking at LEDs and things like that. LEDs are not coherent electromagnetic wave energy. Lasers are coherent electromagnetic wave energies. LEDs will not work. You need coherent electromagnetic wave energy. I've been searching and searching for this, and for the record, this is from United States patent from Stan Myers, number 5149407. So there we have it. This is the process and apparatus for the production of fuel gas and the enhanced release of thermal energy from such gas. And this is really real thorough. He lays it out in this document, pretty much everything. But specifically, yes, I've been trying to find more details about what type of light to use and how to use it. But LEDs will not work. It's not a coherent light source. Final answer. So in my previous kind of videos here, I've talked a little bit about the coherence and light that's needed, and ChatGPT told me that UV light would be the most effective in doing that, but I still need confirmation of what specific laser diodes or whatever Stan used in his project. What frequency? What color were they? Were they visible? Were they UV? I need answers. One other quick footnote here. The electrical load may be a typical power-consuming device, such as a light bulb or resistive heat-producing device. As the positive electrical potential is switched on, that is, pulse applied, the negative charge electrons liberated in the gas resonant cavity are drawn away and enter into resistive load, where they're consumed. There it is, the processor shown in figures 4, 4A, 4B, etc. Treatment chamber is provided that encloses a set of batteries of solid-state lasers, BAM, that are concentrically mounted around a charging cell formed from positively and negatively charged concentric rod and cylinder rod, which are connected to an ionizing voltage source through terminals 54 and 55.
This is Stan's Revenge.
Just something I'm noticing here. I'm pulsing my circuit with about 32 volts maximum here. In this specific patent here, he's got 110 volts coming into this that he's rectifying. So basically, pulse DC, almost DC totally. But we have this pulse DC to this transformer here through the full bridge rectifier. Had to do it. You'll see here the size of these coils here. Let's say I think it's about double that maybe if you slide that guy down, 2/3 at least. So I would speculate that we're putting at least 100 volts into it at this point, close to, let's say maybe close to 200 volts input to the primary coil on this apparatus. Now, holy moly, could you imagine? Now, this is the actual frequency of that you're putting in there. You're still putting pulse DC in here, potentially jacked up to 200 volts, and you're gating that with the trigger input. And you're essentially stuck at 120 hertz for that, but just wanted to kind of recognize that, yeah, we could be putting at least 100 to 200 volts into this thing with the voltage selector. So is that what we need to do? Just dump more voltage in there? How many amps do you think that would consume? And this here being a variable alternate gate circuit, so alternate would be like one on, one off, if I'm not mistaken. So this right here, yeah, we're switching this on during power on cycles, and then when that's off, but not necessarily for the frequency. That is the gate circuit. So we're burr, series of frequencies, then that gate switches, pulls the power, gate switches back, burr, series of pulses, gate switches, repeat the process. Here we go, y'all. Resonant cavity version whatever 0.0. We have a new design here that simplifies this base piece, but these stainless steel strips were actually great for these tubes needing multiple tubes inside of a single vessel, whereas we only have one tube inside a vessel here. These just don't, they're just not going to be perfectly sealed. I did my dangest to these things, but we just can't risk, air seeping out through that. These have to be ultra sealed. So with this new design here, we have just screws that we're going to screw in a stainless steel bolt and probably modify this a bit further to have a flat area where we can put another washer or rubber O-ring seal and a washer and a nut on top of that to really seal these things on both ends. We've got the innermost tube here, the small tube that sinks further down into this right there to where we can connect a lead screw to it, and then the outer one goes to this one right here on the inside. If you really can't see anything like that, just a bit different to where we have the essentially the seal for this outer tube right around that seals very nicely into that. Had to go a little bit size smaller on this for it to fit. As far as the O-ring, that was just for my reference here, a number 35 1/2-inch OD, I believe. We decided to scrap the acrylic tube because acrylic, we are finding out, blocks UV light and other bands of light by default, naturally. So we have some crystal quartz glass here that supposedly, according to research here, will transfer all of the available light frequency rays through the material into our resonant cavity. So no blocking of ultraviolet rays, infrared perhaps, things like that. So everything that we're going to be shooting out from the lasers is going to be able to pass through these into the resonant cavity. I believe that's one major mistake that some of these people are using when they're trying to recreate Stan's work, because they use acrylic or plastic tubes and you just can't get the frequencies of light that you need through those. I digress though. We are coming right along here. We are going to make some more modifications of this, print out two pieces like this, replace that thing. We're going to get this thing machined with 2 slots in it on each side for the photons to go into the resonant cavity, and we'll pick it up from there. We've got a lot to do and a lot more prototypes to make. From our testing here, just our blow tests, we have the completely sealed unit here without even clamping down the seal like we intend to here. We have a very good seal with this thing as is, so we should be on the right track here. Excited to get these things in production. We're going to attach these to a piece like this right here, so we can literally just attach it on top of another resonant cavity So we can produce the hydrogen, oxygen gases, put them through this device, either have it submerged in water still, like have another chamber on top of that, so the entire thing is either going to be submerged in water, or we may experiment with just the gas portion of it, and that is just have the water filled up to here and just have the gases flowing through it. Per Stan's apparatus, there's typically a series of 3 cells, what I believe the ones that are underwater, the water resonant chambers, and then we have the hydrogen gas gun, which is just essentially the same thing but different on top here, just processing the gases. We've got another piece here. This is the Photon grid that we're going to be putting on the resonant cavity. I'll let you know what happens from here.
This is Stan's Revenge.